Hello friends, welcome to Mohsin Mullah Interactive Tutorials. In this video, I am going to explain how to obtain Laplace transform of the given signal f of t. So in this case, the given signal f of t is a sawtooth signal. Okay, so the shape of that sawtooth signal is as shown in this figure here. Now if you observe closely, this signal is resembling one of the standard signals available to us, which is a ramp type of signal. So if I see it closely, it looks like a ramp function. So therefore I can take a standard ramp function and start building this particular signal by using that ramp function. So now one information you need to observe from this given figure is what is the slope of the given signal. So if I see here, the width is 1 unit and the height is also 1 unit, therefore the slope of this particular signal is 1. So it is a unit slope signal. So and even the standard ramp signal which is defined is also called as unit ramp function, and its starting instant is 0 and it has a slope of 1 throughout its time. Okay, so here the time t. So as long as time is considered, the slope of that magnitude in is 1. That means for every increase in 1 unit of time, the magnitude of the signal also increases by 1 unit. Okay, so like this for all the instants, so the magnitude of this ramp signal will be increasing, so in a ramp fashion. That's why it is called as a ramp signal. And it is, say for example, we take this particular signal as f1 of t, which is defined by r of t. So here the slope is 1, so 1 into r of t. So now here we can use this signal to construct the required f of t. What you need to observe is, so the given f of t is existing only between 0 to instant 1. Okay, so it is existing only between instant 0 to 1. Therefore we have to try to end the given this new f1 of t between 0 to 1. So the ramp here is continuously increasing from 0 till t equal to infinity, but we have to end it at time t equal to 1. So in order to do that, what we can do is we have to use another signal which will cancel the magnitude of this positive going ramp from the instant 1. So I will take another signal here which is a negative ramp signal. So to cancel a ramp signal, we have to make use of a ramp signal only, but in the opposite direction. Now the ramp signal should be starting from instant 1 in order to end the signal at instant 1. If I start it from 0, then it will cancel the entire positive ramp right from 0, but I want to cancel the ramp from instant 1, so therefore I have to start the new signal, say f2 of t, from instant 1. Okay, so we'll write the defining equation later. So it has to start from here. Now what is the slope of this particular signal? So this particular signal is also having slope equal to 1. So to cancel the positive slope of 1, we need a negative slope of 1. So therefore I will take a negative going ramp function with negative slope like this. Okay, so if I write the slope of this function here, again it is 1, but it is in the opposite direction, so minus 1. Okay, so now here at instant 2, at instant 1 the magnitude is 0 for this signal, at instant 2 the magnitude is 1, or rather it is minus 1. At instant 3 here the magnitude of this signal will be minus 2. Okay, so like this ramp is going to increase, and defining equation of this particular signal is minus 1 into r of, so usually it is t, but now this signal has started from instant 1, so it will be t minus 1. Okay, so minus r of t minus 1 is the new ramp function which will cancel the positive going slope from instant 1 till infinity, because this signal is also continuously increasing till infinity here. Okay, So now let us add these two signals in order to obtain the resultant signal. Here let me add these two signals, say f1 of t plus f2 of t I will do here. So when I add these two signals, f1 of t plus f2 of t, okay, so for all the instants how to add them. So instant 1, instant 2, instant 3, instant 4, 5, so on up to infinity. So now instant by instant we have to see magnitudes of the two signals here. So first signal is starting from 0 and it is having a magnitude of 1 at instant 1. So for second signal is having magnitude of 0 from 0 to 1. So therefore this magnitude plus 0 will be the same magnitude available here. Okay, so same magnitude will be available up to instant 1 here. Okay. Up to instant 1. Now at instant 1, here first signal is having magnitude of 1, second signal is having magnitude of 0, but at after instant 1, say next instant is 2, at that instant the magnitude of the second signal is minus 1 and here the magnitude of the first signal is 2. So here it is 2 and here it is minus 1. So here what will happen? 2 minus 1. So at instant 2 it is 2 minus 1. So 2 minus 1 is again 1. So say this is the height 1. Similarly at instant 3 here the magnitude is 3, here the magnitude is minus 2. So therefore at instant 3 it is 3 minus 2, again the magnitude will be 1. So on it will continue, 4 minus 3, for next instant it will be 4 minus 3, 5 minus 4, etc. So for all the instants, so the magnitude of this particular signal will stay constant from instant 1 onwards till infinity. So this will continue up to infinity. Okay, so everywhere the magnitude is 1 here. Okay, so all of these magnitudes are 1. So now we have got ramp available between 0 to 1, but then onwards what we have got is a positive step type of signal. But our requirement in the f of t, if you see, the signal is ended at instant 1. So in order to do that we have to cancel the negative slope, here this positive unit step function by using a negative step function. So I will take another signal which is nothing but f3 of t. Okay, so I am going to take a new signal which is f3 of t. So that f3 of t is taken in order to cancel this positive going slope. So in order to cancel the positive type of unit step function, so we have to take a negative unit step function. So we will define it later. So what we need here, there is a magnitude of plus 1 in this particular sum of the two signals. Okay, so the magnitude is 1 here entirely, and here to cancel the positive one we have to take negative one. So in order to do that I will take a signal starting from instant 1 having a magnitude of minus 1 throughout its time instant. So minus 1, but it has to start from 1 because we have to cancel from instant 1 only. Okay, so therefore when I add these two signals, which is earlier signal and this f3 of t, so I will get the resultant signal as the required f of t. So we will write first the defining expression for f3 of t. So this signal is a unit step function with negative magnitude, so minus u of, now instead of t it is t minus 1 because it has been delayed by unit 1, okay, time 1. So u of t minus 1. Okay, so when I add f1 of t plus f2 of t and the new signal f3 of t, I am going to get the resultant signal which is the required signal over here. So now the final signal f of t. So this f of t will be obtained by using the first sum of the two signals, f1 of t plus f2 of t, now plus the new signal f3 of t. Okay. So when I add these signals, what I am going to get is a ramp signal having a magnitude of 1 and ending at instant 1. So this is my required signal. So now I have constructed this shape by using standard function, which are represented by f1 of t, f2 of t and f3 of t. So therefore I can write f of t equal to, therefore f of t is nothing but the sum of these three signals, f1 of t plus f2 of t plus f3 of t. Now in order to obtain the Laplace transform of the given signal, simply we have to obtain Laplace transform of f of t. Okay, so that Laplace transform will be obtained like this. Laplace transform of f of t equal to Laplace transform of the three signals, f1 of t, f2 of t plus f3 of t. Now substituting their corresponding expressions here, Laplace transform f1 of t is what? The first signal. f1 of t is what? The first signal here. r of t second, f2 of t is what? The second signal, okay, this one, and f3 of t is this signal. Okay, so we have to add all these three signals here. So first one was r of t, then Laplace transform of minus r of t minus 1 plus Laplace transform of third signal is minus u of t minus 1. Okay, so now we know the Laplace transform of each of these standard functions. So Laplace transform of r of t is 1 over s square plus Laplace transform of r of t with shift of 1 unit is represented as e raised to minus shift s divided by 1 by s square. Since the sign is minus here, so this sign will become minus over here. Next, the Laplace transform of next signal is again with the negative sign. So that Laplace transform is, so Laplace transform of u of t is 1 over s, but now it is with the shift, so that shift is of 1 unit, so e raised to minus s. So this is the required Laplace transform of f of t, or it can be written as f of s.